Okay, so I've gone back to making the videos because it makes sense for me to figure out what I'm doing. So we're looking at electroplating and Faraday's first law. So be careful with Faraday's because he did lots of stuff. He's an amazing guy, worked in electrochemistry and electricity back in that time when you weren't so specialised. Also started the Christmas lectures that are very famous in the UK and made lots of people love science. So make sure you're looking at his laws of electrolysis, not his laws of something else to do with electricity that I can't remember off the top of my head. So make sure it's all about electrolysis, electroplating, and all of that stuff, not his laws of, I don't know. Make sure you're looking at the right laws and you're not going off on a physics tangent. So, Faraday's. Why do we care about Faraday? Well, why we care about Faraday's law is because when we're looking at adding metals to other metals or electroplating, we want to be able to work out how long it's going to take, how much energy we have to give it, because remember we're putting energy in, we're not getting energy out. We're getting electrical energy in, we're not getting that electrical energy out like our galvanic cells. So remember that we're kind of thinking industrially. We're thinking about, we might just do like a small beaker, we might be still looking at the things, but think this is what people are industrially doing. So industrially, we'll be looking at how, you might electroplate something with some copper, or you might cover it with some chromium, and then that gives it some properties. So think of our properties of metals. You might want iron because it's strong, but then you have that chromium coating, so it's nice and shiny and it's protected, and it's going to be not so likely to rust and degrade. So we've got some stuff to cover. First, we're going to start with our electroplating. So this is the cool bit. This is when we take some metal and we get some more metal. This is what we were talking about. Can we make something silver? Yes, we can, but it's not going to be as exciting as you think. Well, it's pretty exciting. So what we could do, we could get our substance. We could get whatever we wanted and we could make it look like it's silver. We could get something and we could plate it in silver. So this is what they do with some cheap jewelry. This is what they do to coat things so we can use it and have both properties and protect it, or we might use it for spoons, or when we just want a small amount of silver or copper or whatever, we don't want all of it. So what we would do, we would set up, we could do it on a small scale. So we have a beaker or a bucket. Can we see that? Right. And because we are doing our electroplating and we're looking at these, we're not looking at galvanics, we're looking at electrolysis, we need to put electricity in. So we're going to need a electricity supply and mark those two bits. So this is like that beanie thing I made you do when we were on shutdown. We could attach our object to our negative side. So what could be made of metal that I would want to electrolyze? What have I got around? This is a spoon. I've given myself no space. So that's spoon. I decided I want my spoon to be covered in silver, so I look like one of those fancy people who has silver cutlery. I've taken my spoon. This side is going to be my cathode. It's negative because you've got these electrons coming in this side. Yeah. Electricity is coming down this side and pushing into here. Then we've got the other side, which is my anode. And that would just be a silver rod. So it could be just a lump of silver rod. It would be something like that. Well, how come I have the money to do this and not the money to just buy that? I don't know. Anyway, so I've got this silver rod. Maybe I've nicked it from somewhere and decided I'm going to hide the evidence by covering everything I own in silver. I'm like a silver version of Dr. Evil. Then I'm going to need my fluid, my electrolytes in. And I want something with the silver. So remember from our electrochemical series, I'm losing my mind, that this is one of the ones we can do aqueous. Remember, it's between those two things. We'll probably go through that as some revision. But we've got an aqueous solution. So what we've really got in here is these two little ions roaming around doing their thing. So because we've got this side being a negative and then this side is our positive, what we've got happening is, because this is positive, we're going to be losing, and there's some good animations that are not my drawings. We're going to be losing, I don't have a different colour, oh yeah I do. And this is why I say watch the Eduardo woman, she doesn't have to go get out the pens. Right, so we've got these silver ions and they are coming off of our silver. So because we're giving it that positive, we've got our little silver ions coming off. So little silver ions are here, it comes off and becomes dissolved in here. Then either this one or this one, it kind of is the same. It's going to be kind of floating around, doing its thing. Ooh. And then it's going to get close to this, and because it's got this negative charge, it's going to be attracted to it. And then it's going to gain that electron, and it's going to go from an Ag plus to just a little Ag. And it's just going to be stuck on there, so it's going to stick in this little silvery layer. And eventually, after I've left it for whatever time I work out, using my next couple of laws, I'll get my nice silver spoon. So this is going to increase in mass because I've got that little layer of silver just covering it. And then this is going to decrease in mass because we've got those silver ions being lost. So the silver's coming off here, this is going to decrease in size, and this is going to increase in size. And what we can do eventually is measure that. So that's my electroplating. Think about some of the things you might want to do large scale. So why won't they use this? Would they always use aqueous solutions? Would they sometimes have to use molten? Think about that in terms of what we've done. Next video, we do Faraday's first law, and I'll do a question as well. Oh.